Still on chapter 21, and this talk is going to start off by discussing antigen-presenting cells. So what antigen-presenting cells do is they engulf antigens and present these fragments of antigens to T cells for recognition. The major types are dendritic cells, macrophages, and B cells. Excuse me. Dendritic cells are found in connective tissues and the epidermis, and they just basically phagocytize pathogens that enter tissues, then enter lymphatics to present antigens to the T cells and lymph nodes. They are the most effective antigen presenter known, and they are the key link between innate and adaptive immunity. That is a dendritic cell. Macrophages, big eaters, widely distributed in connective tissues and lymphoid organs. They also present antigens to T cells, which not only activates the T cell, but further activates the macrophage. And then the activated macrophage becomes a ferocious phagocytic killer, and it can also trigger powerful inflammatory responses and recruit additional defenses. B lymphocytes do not activate naive T cells. They present antigens to helper T cells to assist with their own activation. This is just an overview of B and T lymphocytes, what type of immune response, if they secrete antibodies, their primary targets. So now we're going to talk about the humoral immune response. When a B cell encounters a target antigen, it provides a humoral immune response. Antibodies specific for that particular antigen are going to be produced. So let me go back. That is what the humoral immune response is. The B cells are going to be making plasma cells and memory B cells, and the plasma cells are going to make antibodies, and that's the humoral immune response. So B cells are activated when antigens bind to surface receptors, cross-linking them, and this triggers this receptor-mediated endocytosis, don't worry about that part, of the antigen receptor complexes, which is going to lead to the proliferation and differentiation of B cells into effector cells. And I mentioned this earlier. So most clone cells become plasma cells, which are antibody-secreting effector cells. And they secrete antibodies at a rate of 2,000 molecules per second for 4 to 5 days, then they die. Antibodies are going to circulate around in the blood and the lymph, binding to free antigens, which is going to mark them for destruction by innate or other adaptive mechanisms. So what this is showing is we're binding the antigen to the B cell. Clone cells that do not become plasma cells become memory cells. And these memory cells are going to provide immunological memory. And this is going to help mount an immediate response to future exposures to the same antigen. So remember when we talked about the adaptive immune system, we talked about the shortcoming is the fact that it needs to be primed. And once these memory cells are in place, it is primed. So any second or subsequent exposure, the immune system can respond immediately. So, oh, I see. I missed part of the slide earlier. That's okay. Let me go back up to that. So this was just showing that the antigen binds, and then this is going to proliferate into active B cells, and then these active B cells are going to make plasma cells, right? Or memory B cells. And these plasma cells are going to make antibodies. So this would be like a first response, a primary response. So you see that, and this again is going to take some time. This is not going to be immediate. Subsequent exposures, when the antigens bind, it's going to trigger a larger, more rapid response. So you can see lots more plasma cells are being produced, which are going to secrete a lot more antibodies, or a lot more antibody. The primary immune response, so cell proliferation and differentiation upon exposure to the antigen for the first time. So the primary immune response is the first time you are exposed to this antigen, whatever the antigen is. There's a lag period of 3 to 6 days. So you can see that's what it was talking about. The system has to be primed, and that takes time. And it takes 3 to 6 days amount of time. And peak levels of plasma antibody are reached in 10 days. Antibody levels then decline. All right. After you are exposed to the same antigen a second and subsequent time, there's going to be a much more effective response. So you have sensitized memory cells provide immunological memory. They're going to respond within hours, not days. Peak levels of antibodies in about 2 to 3 days, and at much higher levels. Antibodies bind with greater affinity, and the antibody level can remain high for weeks to months. So what this graph is showing, as soon as I get a cursor, there we go. So we have exposure to antigen. This is day 0. It takes about 3 to 6 days, and then the levels of antibody go up. And then it goes down pretty rapidly. Okay. This is a second exposure to antigen A. This is what we were talking about. First exposure to antigen A, second exposure to antigen A. And you can see it's almost immediate. It goes right up, 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 much, much higher. And then the levels do not drop off as rapidly as they did after the primary response. This is also showing that antigen B, at this point, the person's being exposed to antigen B right here. And so even though they're exposed to A and B, A again is going to go up, but they've never been exposed to B before. So then it still takes 3 to 6 days for the levels of the antibodies to B to be produced. Active humoral immunity occurs when B cells encounter antigens and produce specific body antibodies against them. And there's 2 types of active humoral immunity. Okay, so I'm about to talk about 4 different things. 2 things on this slide and then 2 things on the next slide. And make sure, and then there's going to be a chart that kind of like puts it out in a nice, neat fashion. But make sure that you keep these separate. So this is active humoral immunity. We have naturally acquired, and naturally acquired is going to be formed when you are exposed to bacteria, or it's going to be in response to a bacterial or viral infection. So naturally acquired means you naturally are getting it, right? You're in your environment, you picked up a microbe from a doorknob, right? Artificially acquired is going to be in response to a vaccine of a dead or attenuated pathogen. So you're still being exposed to the pathogen. It's just either dead or attenuated, and attenuated means changed in such a way that its virulence is not as bad, which just means it's not as dangerous. And provide antigenic determinants that are immunogenic and reactive, and spare symptoms of the primary response. So that's what a vaccine does. A vaccine provides antigenic determinants that are immunogenic and reactive, and it also spares the symptoms of a primary response. Then we have passive humoral immunity, and this is going to occur when ready-made antibodies are introduced into the body. So B cells, so this is really important. In this scenario with passive humoral immunity, B cells are not being challenged by antigens. Because of the fact that they're not being challenged by antigens, They are not making memory B cells. Therefore, immunological memory does not occur. Protection with this type of immunity is going to end when the antibodies degrade. And there are two types of passive humoral immunity. There's naturally acquired, and this is antibodies delivered to a fetus via the placenta or an infant through milk, or artificially acquired through the use of getting an injection of serum like GABA globulin. Now, it does provide immediate protection, but it's going to end whenever the antibodies naturally degrade in the body. So we have this broken out. Humoral immunity, we have active and passive. Active, naturally acquired, means you're actually getting the infection. You've got contact with the pathogen. Artificially acquired would be vaccine. We have passive, naturally acquired is going to be antibodies passed from mom to fetus or mom to infant. And artificially acquired is going to be an injection of exogenous antibodies like GABA globulin. These are your questions. All right, you guys have a good day.